Hello everyone, welcome to Marina's Point. We are going to solve electrical lesson question. You can see question on the screen. The open circuit voltage of a cell is measured by voltmeter of 100 ohm resistance was 1.5 voltage is given, and the potential difference when supplying current to a 10 ohm resistance was 1.25 volt, which is measured by the same voltmeter. Now we have to calculate define the EMF and internal resistance of the cell. Now, first I will write the given data which are given in the question. Then we will go step by step what I have to calculate. We have to calculate EMF and internal resistance of the cell. First I will write data given. In the question it is given voltmeter resistance denoted by RV is equal to 100 ohm and load resistance is given which is equal to 10 ohm. Voltmeter reading on open circuit is 1.5 volt. Voltmeter reading when supplying current to load is 1.25 volt. These are the data given in the question. Now we have to calculate EMF of the cell and internal resistance which is denoted by a small r of the cell we have to calculate. Next we will go to calculate EMF of the cell. Condition open circuit condition. When the cell is open circuited, the voltmeter of 100 ohm is connected directly across the cell. This is the condition. Open circuit condition is given. In that condition, voltmeter of 100 ohm is connected directly across the cell. So the measured voltage 1.5 is not exactly E because the small current flow through the voltmeter. Understand? In the open circuit, what happened? The voltmeter of 100 ohm is connected directly across the cell. So, measured voltage which is equal to 1.5 is not exactly E because a small current passing through the voltmeter. So, we have to assume some current passing through voltmeter. The current passing through the voltmeter formula we will use simple I is equal to V by R. Here, potential difference is E and total resistance RV plus a small internal resistance. Okay, now we can write voltmeter reading. Voltmeter is reading across the resistance given. So it will be V1 is equal to I1 RV. Now I1 we already calculated. We will put the value and we will get voltmeter reading. Okay. Now V1 is given. Voltmeter reading across the resistance is given, but it is given open circuit. So that's why a small current flowing through the voltmeter. That's why we take a small resistance across voltmeter. Now, using the formula, we have calculated E1 is equal to RV plus R, and we put formula here. V1 is equal to I1 RV. So we put the value of I1 in second. Voltmeter reading V1 is equal to I1 R1. So here we are putting I1 here. Then we are getting the equation and V1 is given and we simply put the value 1.5 volt here and one equation we get. Next, when 10 ohm load is connected, now voltmeter, what happened? Voltmeter 100 ohm and load 10 ohm are connected in parallel. Now 10 load is connected. In the first condition, open circuit. So what happened? Both are across the cell. So first I will calculate the equivalent resistance. If it is in parallel, then equivalent resistance, it will become like this. R1 into R2 divided by R1 plus R2. So equivalent resistance will come this one, and simply putting the value we will get combined resistance across the cell. Now we have combined resistance, but total resistance we have to take voltmeter resistance, internal resistance, which will be in series. So now equivalent resistance will be R plus RB because it is in series, and these two are load. 10 ohm is load is connected, which are in parallel. So equivalent resistance will be calculated, and after that we find equivalent resistance across voltmeter, including internal resistance. Okay. Now same formula we will apply. I is equal to V by R. So here E divided by R plus RP we already calculated. We have to calculate internal resistance, and V2 in the second condition is also given. Simply I2 into R2, here I2 into RP, I2 we will put, and then we will get this equation, and simply V2 is given in the question, and we will put value of voltage 1.25, and then we will get second equation. Now we will solve this question, both equation. We will find the internal resistance value you can see in this question, and we will get internal resistance in this one. We get two equation. Now solving equation 1 and 2, from 1 and 2 you can get this one. Substituting in second, you can see from first equation we will get, now substituting in second equation we will get this one, and now making this equation very simple, we multiply it by this one and getting equation simple. And now we have to simply solve this internal resistance we will get. Okay, thank you.